we put the collections of all intervals of this form on which the initial value problem has a solution. Beta from this interval to Rn. Yeah, so we put all the intervals. Whenever there's a solution, we just consider that as a possible interval, right? So that's a collection of intervals, and we use this letter to represent all the I, collection of all intervals. So here we will construct. Here's another notation. The L is a collection of all the left end points, right, of such intervals. So L is the set of left end points of some intervals in that collection. So this is the collection of intervals. For all these collections of intervals, each one has a left point. Then we put all the left end points into the set L. L means left. Okay, so that's the name of the set. That's another notation. And here's another notation. It's another set. It's the set of right end points of the intervals. Right, in this collection of intervals, we put all the right end points in this set. Okay, so other notations. Yeah, and by the way, we note that because this is an interval on which there's a solution, we know S is in all the intervals, right? For whatever interval you take one, we know S is a point of that interval. Why? Because if that's an interval, there's a solution, then S, when time is S, we have C, right? So S has to be interior point of the interval for all intervals. Okay, so after we have defined all this, we also note that S is in each interval, right? J, each interval. Yeah, so now we're ready. We're ready to construct the largest possible interval. Okay, so first we want to find the left point of the interval, right? Any question on the notations so far?
Yeah, can we write that S is in the intersection of all the J's?
So S is in each interval.
Right.
Because each interval is an interval where there is a solution to the initial value problem. Right? So if it's an interval where you have a solution, so this solution is X, right? Right now we're using beta to denote the solution. So let's say if we use X, the solution from some interval, right? Which is denoted by J so far.
So all the T's have to be in J.
Yeah, T has to be in J. In T, you see this S is one of the T's, right?
Right.
Yeah. So S has to be in J as well. So yeah, S has to be between A and B.
I was just thinking of it like in, it has to be in the intersection of every one, because if it's in every one, then.
Yes, it's a point in every such intervals.
Right.
Yeah. Whenever you give me an interval where there's a solution, then the interval must include S as an interior point. Yes. Okay, so because otherwise how can you define S, right? At this point, S we have to, because that's a solution satisfying initial condition, right? So yeah, S has to be in this so that you can find the integral curve or solution curve. Yeah, so now let's construct the largest possible interval. So the left point of the largest possible interval, what do you think should be? We just define L to be, okay, this is the collection of all the left endpoints, right? To be the infimium of all the left endpoints. So L is infimium of all the A. A is in this collection. Okay, collection of all the left endpoints. So we pick the greatest lower bound.